Okay. Okay, again, good morning, students. The topic of today's lecture is electronic medical health records and also approach for the design, development, and development of hospital information systems. So, EMR, EHR, it will be like the first part of the lecture, and developmental question will be the second. In fact, we already have some points with EMR introduction previous times. So some question for today I will pass through relatively faster to just make necessary important points, and then we'll make more emphasis on developmental question. Okay, so of course we need to get back into understanding of medical records basics, definitions of EMR/EHR, and implementation and interoperability questions. So that's the point I will make more emphasis right now, today. So definition, purpose, format, content, and administrative use of EMR usage. Things actually you have to be also maybe already familiar or will be study very soon on a few departments in our university, but still we will touch this point right now. So we have to consider medical records, medical chart, and so on, as a systematic documentation of patient medical history care. So for decades, it was cover like physical storage along with body information. In physical storage, we had understand usually folders with a bunch of papers and so on. Actually, in recent decades, we observe and we perform migration all around the world, migration of medical records in digital format already. So general information in medical records will healthcare providers to provide continuity care to individual patients. And also it serves as basis for planning patient care, document communication, healthcare providers, and so on. And even, of course, it's a valuable source for scientific information, for various audit and quality assurance question, and even tool for education, of course, because that's how in other we can study specific cases. So, of course, content of medical records might vary, but depend of specialty and location, but generally contains some basic information like identification, health history, so specific family history, and so on, and then medical examination findings, different observation, and also as well any recordable data, lab test results, images, prescriptions, referrals, and so on. So again, I think that's very common things, and I will pass relatively fast. So, of course, core of medical records and information about each encounter that patient get and claim with, and it has to definitely contain information about chief complaints or problems that patient come, and then history of present illness for this encounter, if already available, it's in the first visit. Then, of course, current physical examination information, what's physician observing right now from patient, and assessment plan initial and further information summation about what has to be what this case caused by and what it has to be done. So then, of course, different orders, if available, already test results, notes on progress, and any suitable information, and so on. So, as I already mentioned, we are for already decades, we are in progress to moving to fully digital representation of medical care, because obviously it's provide number of benefits for after it's had been introduced, like better access, instant availability of information, ability to combine different type of information, including all kinds of multimedia data, images, multimedia data, and so on. Of course, ability, at least potential to exchange of information between facility, and some additional benefits, including like chatting, easy accounting, and so on, statistical access, educational access, if available, and so on. So I have plenty of reasons to adopt. And of course, some disadvantage available as well, because in case of digital system failure, we are at risk not to be able to access any patient record at all. And it happens from time to time. Previous time I already spoken about different types of electronic medical records, what is EMR, EHR, PHR. Have different. So again, I will repeat the same diagram and remind you that per different medical providers for the same one patient visit different medical providers. So multiply EMR had been created per providers, and with presence of national-wide information, medical information data network, or national-wide each medical information system in place, so EHR could be created by summarizing information from all those EMR. And when patient given access to particular part of this information, so that part patient access or create or manage by himself, covered PHR or personal medical records. So EMR, electronic medical records per provider, EHR, integrated records across multiple providers on the same patient, and personal managed speech. So, what is like some most important points of ideal EHR? So first of all, it's of course its ability should be information must be, not should be continuously updated and maintained. So here is critical point, in fact, and sometimes it's like by many still I notice a different report, different scientific publication, which spoken about issues with update and maintain it of electronic medical records, which different countries, hospitals suffers, and due to some different reasons. So, of course, much of benefits from EMR HR we got if we will have as many information and as precise as possible. Unfortunately, despite already long history of practical implementation, still sometimes that's we have problems. No, because actually main reason that it's like time. So major complaint from physicians they don't have time for properly film EMR, and so on. And so then I move to the third point right now at this slide. It's ability to exchange between different health systems or interoperability. So in modern time, it's absolute necessity. It's absolute necessity when hospitals being not only equipped with EMR system, but has to be capable to exchange data with in other facilities, with in other levels of healthcare agents, uh, by using standard methods for data exchange, which is provided by different standards. And then, of course, it's placed here at third place, but actually it's last in line. Its ability to be accessible anonymously for educational, statistical reporting, um, data analysis, and so on. So that's not absolute necessity, but very recommended, very useful things. Okay, in case of interoperability, that's ability to different information technology systems and software application to communicate, exchange data correctly, effectively, and consistently, and use information that has been exchanged. In case of health information, we use term in health information exchange, HIE, or its mobilization of healthcare information electronically across organization with the region or community. Actually, things has been taken like by serious attention by governments from the beginning of 21st century. For example, United States, it's only in 2004, Special Office, National Office of Coordination of Healthcare Information Technology had been created in order to address interoperability issues. And only that year, National Health Information Network had been established. So it's like just 20 years ago. And actually, uh, mm, not only medical information system, but even standards for data exchange had been already available for decade, for about also another 20 years before that moment. But it just indicates that those standards, those recommendations were not widely adopted, even in say, high development country like US, even by that year. So uh, and since that, many significant change had been made, not only in US, because very soon after, similar organization had been established in the European Union, and some Asian countries also have their own solution in this case. But still, there are many of issues with interoperability. As you can see, we have this chart which present some full or partial support for steps in data exchange between medical information system. And here is given some comparative analysis. It's a little bit outdated information, but I was unable to find some updates in this report. So still 5 years old data, and still even United States and even some European country, we have issues when we have not all three dots, not full support, and sometimes only uh, very little support provided. So as we can see, we have many significant issues in many countries. Of course, more problem we have with developmental countries, but still, uh, that's establishing interoperability on a national wide basis. It's really not easy task, and it's usually not easy to accomplish this. Speaking of technical solution which help us with establishing of interoperability, I spoken about this during second lecture. If I if I properly remember, where I had spoken about international standards for medical data like HL7. And here is different version of HL7, different data exchange architectures like second level text-based, CDA, which is actually XML-based, and modern JSON-based FHIR implementation, fast healthcare interoperability resources. And their visualization of their adoption and support by most prominent, most modern EMR, EHR vendors. And here is, along with some prediction. In fact, this again chat a little bit outdated in the meanings of just only about this bar present day. It's already moved to right. Moreover, in other case, it's absolutely correct. Moreover, and even a little bit conservative, because adoption of FHR technology rise drastically when CDA V2, V3 architecture already almost gone. So, in case of prediction that FHR will be widely adopted, they were correct, and it's already happened and working this way. So actually, a JSON-based data exchange approach now dominate within those information MIS with our EMR MIS, which are available in market. And here is we have like a very useful tool for data exchange right now, and even few editions of FHIR already published. So they not something single one stable. Despite of this, here is we still have issues with interoperability. Here is more or less recent information about United States. It's already post-COVID. It's from 2022 database, but still it's in yellow. It shows some available disruption and issues with establishing interoperability between different hospital information systems. So here is we have so brightness this color. That's more issues we do have. And of course, I must mention Ukraine. We were in significant delay of introduction EMR and national-wide EHR generally, but it was sometimes due to some organizational, financial issues, but okay, it was many reasons for this. Anyway, in 2017, it was made significant efforts, and finally we got success with introduction of National Health Network. So since that, all facilities in Ukraine, all healthcare facilities in Ukraine obligated to use EMR. It was started gradually for first 2 years, only for first level of healthcare, protecting family, ambulatory family doctors, ambulance family doctors, and so on. Then it had been, since 2020, it had been enforced for larger hospital, second level support, healthcare support, services support. But anyway, by now, actually, even despite war, we have full coverage for all facilities. They are provided and equipped with medical information systems. Or HIS, Hospital Information System, and we have our central system or central database repository, maybe not very correct term in my opinion, because it's actually information system, which include database as well, of course, but it's more than database, in fact. Anyway, this national-wide system allow other host information system to communicate with itself, and through its database repository, information about patient could be shared between different host information systems. So it's no longer necessary to make new registration of patient if it visit new facility, because if he had visited at least family doctor, his information will be already available in system, and it's possible to get access to it, no, except some emergency case which had happened during that time. So just let's say some story does not have chance to translate this pictures, but here is we have actually some statistics about usage of information of e-health in Ukraine by the end of 2024. In fact, National Health Service reporting that actually almost all Ukrainians already registered in system. Most of them, so 37 millions. I don't know how many Ukrainians remain in Ukraine right now, maybe 30 millions, maybe so, maybe even less, because Ukraine suffers mass exodus because of war. Anyway, still we have declared about 31 millions of agreements declaration with family doctors, so it's more or less we can talk about that's number of Ukrainians that's still communicate with their family doctors, even maybe if they had somebody of them outside, out of Ukraine, abroad. And here is we have number of information which is gross chart represent huge growth within recent years when second care level had been added, and registration of all medical encounters in digital format become mandatory since 2021. So here is spoken about 4 billion separate medical records. It's not mean about patient. It's mean in this meaning it's medical encounters. So it's maybe few, no, not many. It's definitely few encounter per person, but here is we got these numbers. And technically, to make some technical notes, yes, Ukrainian Special 7 system is adopt FHIR to data exchange. So we follow standards, and it gives us some benefits to have many actually information systems. So hospitals not limited, they are limited only with those information system which support data exchange with central e-health database. And it's about 30 of different such systems available at Ukrainian market. Within Ukrainian market, so actually available some concurrency, and hospitals could make a choice about system which better suits their needs or will be more affordable also. So finally, to talking about to finalize points about EMR in general, it's also quite important to, if possible, to incorporate old records to complete if we move from paper to digital. So we can't only start new electronic medical records, but it really necessary to gradually incorporate previous paper-based records into new digital to keep EMR also updated and including previous results. So that's actually costly and time-consuming and difficult process, and not without losses. So it's reported about up to 1/5 or even quarter of records, very often difficult to convert into digital form. So a few points about implementation or adoption of process of EMR, new EMR solution. Of course, we have some kind of timeline, some kind of workflow, which should be passed in order to get successful implementation, like make some evaluation and training, have some vision, made some evaluation, made choice about among available solution, then pass through implementation process, including like some quality assurance testing and user training, which is actually extremely essential, and then actually go live, and then again we will have a question related to maintenance, support, upgrade, updates, and so on. So actually it's continuous process, never ending in fact. And again, I would agree that's basic 80 to 20 rule, which is working in all, mostly in all areas, when it spoke that about 80% of work of an EMR implementation must be spent on issues of change management, and only 20 depend to technologies itself. Meaning if we have like enough budget or so, yeah, it will be really true this way, because major things, it's yeah, really, it's various organizational, social issues, which include the restructuring workflow, dealing with physician resistant to change, the personnel resistant to design and implement flexibility needed in complex healthcare environment, and so on. So really, most things lie into organizational social issues, into management changes. Actually had the number of personal experience related to this, because had been involved in few projects related to implementation of EMR even before it's become national requirements. So had a chance to see this in practice, in reality, how it is. Usually, technical limitation can be much easier solved than organization. So more or less, given numbers may be a little bit updated, but not really serious, because again, I had seen number of failures and cancellation of EMR project before it was ordered again and enforced as national-wide solution. So actually, just commercial clinics, non-governmental commercial organization were more successful in implementation of EMR project, and actually almost all project I have now about when it was before 2017, before it was enforced by government, most of attempts to start digitization into like governmental or community clinics, most of them fail. And usually, yes, we are over budget. overschedule it, and very often we have issues with scope and functionality. Unfortunately, it still happens even today. So physician, even with modern system, physician very often complains about lack of some features and high expenses for maintenance and support and so on. So unfortunately, year of issues still preserved, even with modern relatively success in speaking about Ukraine. Uh, So if we talk about factors which led to failures, it's of course lack of training, unclear vision or goals and approach, or incomplete, unclear and changing requirements, lack of executive support and commitment. So that third point, it was again, uh, it was actually almost no successful implementation in community governmental healthcare facilities of MIS until government become commitment to this and enforce it in 2018. 2017 started and 18 completed. And then, of course, lack of resources, staff time, money, of course, critical. Yeah, why not? And so sometimes unrealistic expectation. The combination of lack of vision and planning, it's very dangerous combination. It's possible. So I had seen all this personally in Ukraine. Anyway, we have some information and statistics about here is like barriers for implementation. No, here is spoken about high development country, United States, European Union. So even in this case, startup cost, it's second after privacy and security. Even for highly developed countries, it's very significant implementation barrier. So a little bit outdated information, but such as we are at a high level of implementation right now, barely will be available new data for EU and the United States, so maybe only for developmental country. And here is we have some statistics which is related to adoption of EHR, EMR system on different country. Here is especially we have case for European Union. Not all country have reported some level, mostly European Union, but not only, such as you can see there are a few countries outside of EU just to be compared because they are members of OECD. So anyway, as you can see, with leaders Finland, yeah, they are actually have accomplished almost everything in perfect on perfect level. In other case, even such high developed countries like United States or Germany have many issues with this. And again, who is next? Like Baltic states, like for example Estonia, and so on. So still, as you can see, we have number of issues with implementation of and adoption of EHR. And even sometimes decline. Here is another statistics about usage of e-prescription. Here is again a little bit outdated information, but you see largest country in EU has a lot of issue with this solution. And again, as what is interesting, Scandinavian states, Great Britain, Spain, Italy, they have demonstrate great success in usage of prescribing systems. Adoption, status of adoption, United States, here is even more difficult to find information for some reason. For already for a long period, I don't have realistic information. Anyway, it's almost complete process, except not all systems are fully certified by USA government. So they could have only that's mostly legal issues, not actually actual problem with data access. And here is some little bit updated information, but most recent I find it was 6 years ago, and it's still like demonstrates that we have high coverage with basic HR, but not like far from perfect in the case of full coverage and comprehensive EHR system. With modern chaotic government, United States, not sure if it will be changed significantly. Okay, few words to complete this part of lecture, just few words about implementation of EMR in development countries. So main issues and popular EMR in that area. So of course, that's we have high mobility in population when people move between different places in for looking for better living condition, jobs, or being forced by different accident and so on. Oh, high issues, limitation with identification of patients, sometimes even number of it, and so on. Then shortage of healthcare workers, shortage of accessing to services, limited infrastructure, medicine facilities, actually everything. Various diseases burden combined with poverty and so on. So many numerical issues. Despite of this, all what I know that even poorest countries in Africa try to introduce some sort of EMR solution, EMR HR solution, at least on central level in largest hospitals, largest cities, and so on. Sometimes they already started developing their national networks, because despite of all these issues, communication more or less established between countries, between largest cities in that country. So, and as we have communications, so we can establish EHR network, at least try. And here is just few names about most popular or at least some reported system which is had been used within different developmental country, and that's already for years. We have two systems which dominate around the world, two projects, OpenEMR and OpenEMRs. So two, were both very interesting, provide some little bit different approach, different features, but they have the same goal. That's actually EMR system, clear EMR system dedicated to automate specific facilities. So here is given link, if you're interested, you can check the system. During our further classes, I dedicate one of them to provide some brief information about OpenEMR. Okay, that's actually all about summary about EMR. And now it's time to move to the second part of lecture, to the approaches to the developmental part, which will be dedicated to the ground of EMR EHR systems. So how do they been developed, and what is lie behind user interface, what they are all based on. And here is definitely databases. And actually, I will pay attention mostly to the relational database because probably all I know EMR, EHR solutions, they are based on relational database. Sometimes so-called NoSQL database had been also employed and incorporated into systems because real system usually complex and very often use not a single but few databases, especially when we're talking about HR. But still, most time we rely on relational database. But before we were talking about relational database or their development, so it would be fine to give some definition about what is this, about what's common types, models, database we have, and so on. And before this, again, small recap of what is information system. So, including medical information system, including host information system, or which support both EMR and EHR records, and so on. So generally, a system of person, data activities that process data and information in organization, including manual and automated process. And of course, we are interested into computer-based information system, which is information technologies component of information system. And in case if we talk about again host information system, so our goal is support maintain of electronic medical records, electronic health records, and incorporates all available information about patient health into this. And here is we have, like I showed again, previous lecture, previous time, a different type of automation system from those who are dedicated to support EMR HR information to more specialized like PACS for radio, for processing medical images, LIMS to manage clinical laboratory, and so on. Still, they are all has to be interconnected together with, for example, interoperability features and tools like FHIR instruments. And here is, if we talk about logical structure, for example, of typical hospital or clinical information system. So here is, we will see something like this drawing, which actually reflect available databases which had been used in this system. And like I said, it's usually more than one. Or yet again, a diagram which I already shown for you when I spoken about PACS RIS. And here is also you can notice that the same icons which reflect database. So from here we have to understand that actually any and all medical information system use one or few database to store and manage data. That's like mandatory components. We can't build system without it. So what is this? Many definitions you can find there are on network. So just two examples. We can make it as brief as possible. Computerized record-keeping system. But little bit better definition, it's system which involve data or then hardware or including networking that's physically stored data, and software that utilize hardware resource in order to store data and provides standardized methods for retrieving and changing data, and users return data information. So second for me, a little bit better. Just I would add there in that part when we talking about software utilize hardware in order to store data and provide standardized methods, I would add the third point or middle point, organize data. Organize data because it's critical point into definition of database. It's even if the simplest definition could be extended, computerized record keeping system, organized record keeping system. So organized, structured, it's most important point in definition of database. So we have our data organized here and structured. So practically, end user usually deal with different user interface of medical information system, like two examples at left side. But what do they? Maybe they have to be aware. It's about presence of the right side. So what is behind their client app? If it's the database, or here in this case, it's talking about SQL, relational database, or even more detailed, and for me it's better, it's called a picture, but it's better reflect real case when we have user database application, but behind this we have two components. First of all, we have database management system, yet another software which designated to manage our use requests from users database application, and by using those requests manage data in that physical storage in actual database. So when we talk about SQL database, it's in fact composed by two components: database management system and actual database which physically store data. So by existence of DBMS, users and developers no need to worry about what kind of data, how data actually really organized in database, because they could use that standardized representation. About types, so here is we have two, usually analytics lab or analytics processes, which is static read-on database with historical data for analysis only. But for us, more interesting second, operational databases or OTP, online transaction processing, that's dedicated for manage dynamic bit of data. So that's actually all working systems represent OLTP. And when we are talking about medical information systems, that say always OLTP, and only after some quite significant time, even maybe patient demise, the record moved into analytical part, such as they are no longer have to be updated. And when we're talking about development of some software, database software solution, that's proper database model have to be chosen. Historically, we have 5 basic database model. Actually, just few of them in use. So of course, for a long time, even spreadsheet had been used, and even text files or flat files. So still could be used for small piece of data even today, like for personal research or so, but actually impossible to use for nothing seriously right now. Hierarchical, defined hierarchical arranged data model. Network model use set theory and generate tree-like structure. Actually very effective database model, but very hard to maintain and manage data. So practically, most of modern solution based on relational database or object-oriented or post-relational database. So here is we have all these models shown in chart. Here is we have in flat file model actually text file, hierarchical, useful in case if we talk about tree-like structure. Network model allow having many interconnection between different branches. A relational model use two-dimensional tables, so it allows having information readable by humans. And in fact, object-oriented still its extension of relational model, just in meaning that we could have more flexibility and we could define new entities on the fly, because we keep information in tables about not only data value but about data structures. So less readable but more flexible approach. Okay, in case of hierarchical database, we have problems that we can't add record to child table until it's already incorporated into parent, and redundancy, because in hierarchical database we can't handle many-to-many relationship, which is, I will be speaking more in details about this in soon. So here is we have hierarchical database, and here is problem of redundancy when like person have partial assignments for different departments, so information about this person has to be duplicated. So here is problem of relation of hierarchical database. Actually, hierarchical model, it's only subset of network models. So what is general network model? It's allow many-to-many relationship to be implemented, so we could have connection between different branches. But again, very difficult to understand in this case. So here is actually how it's look like. It's when at some level entity instance in a network model could have more than one parent. Descendant entity have more than one parent, object. In this case, we can implement one-to-many relationship like this one, like this one. These two examples. It's still available solution which support network database model and some high-end enterprise solution, for example, like Facebook. They use such database management solution to manage data. Okay, but again, as I already said, practically most of medical information system, hospital clinical information systems, they are based on database which implements a relational database model. Introduced in 1970s, so more than 50 years ago, 55 actually. Still in use and widely used, and like enormous amount of data collected in all available relational database. So what is essential characteristics of this model? Again, we are talking about logical representation, not actual representation, physical storage representation. So first of all, data represented in form of two-dimensional tables, because it's very natural for humans to deal with data presented in tables. And what is new, for example, compared to spreadsheets which were already available at that year, so that very strict limitation over those tables. Specifically, each table represents some entity, real-world person, place, thing, as well non-material object like events or so. So each one tables represent entity and it's collect information only about this entity. And then, because in real system we have plenty of entities to be implemented, to be data collected on this, so we should have many tables. Each one will represent a single entity, and those tables could be linked by relationship. Entire table, like linked to another, not like in spreadsheet when we have cell-to-cell references. So it's actually time to introduce some additional terminology. Like here is we have. So what's relational table consists of columns, sometimes use the term field, which also strictly define it and contain only specific information. Like we define column for name, email, some date, and so means this column must contain only those type of value. Let's say string value for names, some formatted string for emails, data time for dates, and so on. Each one row uh, designated to store information about one copy of instance or one instance of object, let's say one person. So we have strict limitation over purpose of columns. We have strict limitation over purpose of rows. And how do they are linked? And here is given example. I will again back to this example some little bit later again, but here is given example of two tables. One contain information about department. Second, contain information about person, in this case teachers, because it's university database about designated to manage university. So here is we have like for department we have names, some contact information, but also we have special field called primary key, which provide unique identification for each department. And so we have the same for persons like name, age, unique identificator, but we want to know assignment, current assignment, or any which had happens in past or will happen in future. And in this case, so-called special, another special field had to be added to the person table, foreign key, which will provide information about relationship to department. So we no need to duplicate information about department along each person. We just reuse key value. And based on this key's value, foreign and primary key, core of relational database management system able to fetch information about like people who work on the specific department or department information to be provided along with teacher names and so. Now let's step by step pass through on development of process of relational databases. So like step, more detailed review of relational model, structure is terminology, properties of relational tables, keys, data integrity, and so on. Finally, TPMS. So first of all, of course, when we talk about development of information system generally, and so I had already like dozen of minutes ago, I had presented some steps of development of information system, and of course the development or choice of database management system, and development of database, it's a part of information system development. So again, we need the same steps like planning and definition, so analysis of requirements, create some made some planning, define some key points, for example, identification of those entities that we have to deal with in our database. Then developing of design of database. So called first of all logical model of database which depict all have to depict all entities and their components, their attributes for all views. And here is at the bottom we have the things because we could have many views, different different users of different roles will want to have their own representation of information in database, so they will present another view. They will have different view ontological representation of our data in database. And then we decide about physical model. Actually, we decide about DBMS, which will actually provide some specific physical model of data storage. And then it has to be implemented with given database management system. Then we talk some testing evaluation of that our actually solution give us met our expectation. So same, like another diagram represents same workflow: modeling, design, implementation, and then actually go live, go to production, and support and maintenance. How this database design could be depicted? One of the approach is to drawing of AR diagram, entity relationship diagram, which depict each one entity and its essential characteristics. So, for example, in this case, we have entities in those blue boxes. Some of those boxes, as you can see, expanded, and some have like double borders. It means that at this diagram we don't provide details of these entities. So in fact, or even we have incomplete solution when like this, when we have single bordered rectangles but like no details. Here is in purple we have significant characteristics or attributes for these entities. Sometimes we have descendant attributes, so maybe it's needs some more investigation in this case. Or they might provide connection to another entity. So here is, we have to understand that this entity relationship diagram, it's represent only a very small part of real EHR EMR solution. Usually that's very large, contain hundreds of elements. So as I already said, that relational will represent data in two-dimensional dimensional tables, and we have to understand that it's a logical view of database. Logical view, it's important to understand how those data aligned onto actual data storage. It will be defined by relational database management system. So that software which is responsible to manage physical storage. But having this logical view, which we are no developers, users, system administrators no longer depend to the specific internal implementation of data storage by database management system. They have to know logical structure of the database, and they have to know specific features of, for example, programming language of RDBMS, and it will be enough to manage data to manage any relational database. So that's benefits of that's a logical representation of relational database as two-dimensional table. We have uniform representation from all relational database management system. And only developers of that system are responsible for manage internal representation of this. So I already shown that's above table. The only like specific difference I want to show that it's terminology. When we talk about table, we have here is informal table, informal tabs. We are talking about so-called special branch of mathematical or relational algebra. And when we talk about table, column, and row, it's use that special terms like relation, attribute, and tuple had been used. But usually in database manual, we use term table, field, and record to entitle relational table, to spoken about columns of table, field, and to entitle row or information about particular instance of particular objects. In this case, we are talking about record. So again, further in this lecture, I will use those terms, table, field, record. So as I already said, data relational database, it's collection of relational table. Relational table is object, could be flat file or whatever, it will be decided by RDBMS system, composite set of named columns and arbitrary number of unnamed rows. So columns are always neighbors, rows neighbors. Data value stored intersection of row and column. Columns of tables contain information about attributes of objects. Rows table represent occurrence of things or instance of objects, entities, instance. So here it is. Major properties of relational database. Values should be atomic. Actually, it's already broken with JSON values. So in terms of implementing of FHR solution, sometimes fields could store not atomic value. Anyway, but even in this case, second requirements will be in place. Column value should be of the same kind, or it's story like information about name or email or JSON string. Okay, but it has to be JSON string then. Each row should be unique and different from previous by value of at least one field. Sequence of column is insignificant, sequence of row is insignificant. That's also critical. And each column must have unique name within table, of course. It might happen for her to having same names within different relational tables. So I already spoken about I already entitled features of value atomic, not repeating group or arrays. No, in fact, broken with JSON strings because they are essentially arrays. Speaking of column values, same kind, relational targets mean targets already. I'm sorry, what's happened with my computer? Okay, yeah. What is most important point again, I repeat that its row is unique. Property ensures that the no two rows in the relational table are identical with at least one column or set of columns, that's value of which uniquely identify each row in the table. So actually this spoken about requirements that's so-called field or primary or of the name of primary key must be present. Which at least, it must be at least one field which provide the unique value which will be by guarantee different than for all in other rows in these tables. So critical points is here. Tag sequence, all the things I already in title, so I skip this. Okay, now move to relationship, association between two or more tables and express it in data value of primary and foreign keys. Here is also important to understand. When we're talking about R diagram, entity relationship diagram, relationship visualized as lines between tables and its join particular columns. But it's important to understand that actually relationship established by the data values on logical level, on designing, during design or visualization of data structure. We draw lines to depict relationship. But inside database, by using internal representation, only value of key fields are incorporated into relationship. And in this case, primary key column in table provide values that provide unique identity for each row in table. And foreign key, it's columns, that's value the same as primary key of another table. It's referred to value of primary key from another table. So primary key value never repeated in this in particular table, but foreign key, if you want to refer, for example, if you want to refer patient data, so patient is identified by primary key value, and if you want to, for example, label each examination results or medical image obtained from this patient, so we repeat this primary key value as foreign, so as result, foreign key value will be repeated, but they will be only from the available set of primary keys, so they are not random. And relationship is made between two relational tables, but matching value of foreign key one table with value of primary key in another. So here is again how it could be look like. Here is we have some list of persons, and we provide some extra field to ensure that we will have unique identifier. It's actually not good to use something like passport number, social security number, or something as primary key, because maybe this might have different cases, like some person does not have passport by now, or not have social security, or they are non-residents, but has to be registered in system. So we have many issues in this case. So every time it's created new one synthetic attribute, which will create unique, never repeated value but its own in this particular table of this particular database. And here is that example I already have. When we assign unique never repeated value, for example, to entitled department, when we reuse this value to we can use those value to show which department this particular teacher belonged to or working for. And here is we come to definition of relationship type. So there are actually three. One-to-one relationship. Simplest to understand, it's when at most one instance of entity A it was on instance of entity B, like something like patient and its current address, for example. It's usual one-to-one relationship. Easiest things. But in reality, it might happen that person sometimes move from one location to another after some years, or get a new job opportunity and have to move to another city and so on. And we actually come to the situation when we have to register those changes in location. Here is we have, no, sorry, before this. For this, we have some like products and detailed description or some information, detailed information about patient. So information which not change it to time. So here is it's important. It's a useful way to separate, to keep like less information, only critical information in online table and put some extra details separately and made accessible on demand, on requirement. As I already mentioned, case when like person moved to another location, to another workplace, being reassigned, teacher reassigned to another department or so. So we have to track this movement. And in this case, we have one-to-many relationship. One-to-many relationship when one instance entity A has 0, 1, or many instances of entity B. But one instance B is only every time referred to only a single instance of entity A. So here is we have diagram, correct the R diagram to reflect this case. And in fact, when we talk about one-to-many relationship, it's represent probably 95% of real solution in relational database. Most of cases will be one-to-many solution. And it's plenty of this. For example, many students studied medicine specialty in medical university, or like, let's say we have two groups, like right now on lecture, and each group composed of few students. That's all this case, it's one-to-many relationship between group entity and entity of students, or students and speciality, and so on. So here is example again, educational example, teacher associated for few classes, like today I have delivered 3 classes, 1 lecture and 2 practices for students. So I am at left side, it's like information about myself. And for today I have 3 records, like 3 records with time, start, and ID. And that's only for today, but actually I had a number of classes this week and many classes scheduled for me for the next 2 weeks. So here is we have clearly one-to-many relationship between my records and my classes, and same for my colleagues within informatics department or within other departments in university. So we can place all university teachers at the left side and all classes that has to be delivered at the right side, and we have something like kind of how we can store information about timetable of education. So here is we have simplest case with 2 tables, but in reality it's need more than 2 tables, and it's need a few one-to-many relationship between classes to create really effective representation of timetable, for example, of education. And many-to-many relationship. So when for one instance of entity Bates could be 0, 1, or more instance of entity B, and backward, same for entity B. So in fact, it's actually real representation. If we're talking about all teachers of university and all classes in university, or all teachers and all students, we have many assigned, many classes to be, like, let's say, put at left side teachers, at right side students, and in the middle we will have classes that has to be delivered by many students to many teachers. Sorry, by many teachers to many students. I'm already make some mistakes. So many-to-many actually represent high-level information relationship in the real world. But when we're talking about implementation, there is no direct implementation of many-to-many relationship in the relational database. It's always been split in two or more one-to-many relationship. And in this case, third or fourth, fifth, it might be more. Junction tables has been created for this case. So here is example how it could be just in case not between relay for depict relationship between students and teachers, but only to depict relationship between students and classes, we need enrollments. So here is we have students on the left side, classes at the right side, teachers at even further right side. So, and here is we have two enrollments when students assigned to particular class for particular specialty and the particular department. So we also have to have not only these three tables, but table for teachers, table for departments, and like teachers could move between departments, we will have many-to-many relationship between teacher and department, and so on and so forth. So again, in reality, we have plenty of many-to-many relationship in our entire informational model for database, but practically they are always all has to be split, separate into larger number of one-to-many relationship. Let's say in this case, business case, we have orders, products, and order details. So which particular products in which quantities had been shipped with specific order, and so on. When order and products contain just basic information about both this case. So again, we have one many-to-many relationship split into pair of one-to-many, and so on. That's actually explanation for this. So integrity referential. Now integrity mean in part that you can correctly and consistently navigate, manipulate the tables in database, and identity rule states that value of primary key never to be a null value, in essence better never to be changed, and referential integrity states that if relational table is foreign keys, then every value of the foreign key must either be null or match value of relational table that which is a primary key. So we must not have something like orphaned value in foreign key. That's break referential integrity. And it could be actual optimal database structure could be achieved through so-called normalization process. This goal of normalization creates a set of relational tables that's free of redundant data and can be consistently correctly modified. Actually, normalization theory, again, it's a set of relational theory based on relational algebra and introduce concept of normal forms. There are 5 of them, but usual normalization end up with third normal form. So actually, when we talk about normalization, we put data or data samples into tabular form and remove repeating group, and then remove duplication data from relational tables. And in this way, for example, when we move so we have to remove repeating groups. In this case, instead of having 3 columns for classes, we put it all under something class ID. And we collect information from all the 3 columns into single one. So here is this way. We, of course, have in fast normal form, but we have multiply repetition for like student name, for teacher name, for room, and so on. So further normalization will include moving into second normal form when non-K column fully depend upon primary key. So for example, we separate students from like registration or registration for classes. And in this case, we will have information about students along with advisor and room for advisor, and then we have students assignments to classes. So here is we have data in second normal form, And final point is to separate it's elimination of any functional dependency. And in this case, we have information about advisor teacher. It's functional dependent on advisor attribute. So we separate again, we separate students from faculty members, from teachers, create yet another reference. So, and we have something like this one, and we can come to a solution like at the bottom, which show for us a database table in normalized form. Normalized form. And finally, a few words about the base management system, base management software. Software package computer program that's control creation, maintenance, and usage of database. Of course, it's dedicated to being used by professional database administrators and developers, of course, but some database also available support for ordinary users. And actually, the database management system define how physically data will be stored. And again, it's eliminate necessity for users, administrators, developers to know details about this because that RDBMS interface usually standardized. So they have to learn only this standard language and they will be able to deal with any DBMS. Sometimes development process even could be managed in visual form. So here is we have special tools which allow to create our entity relationship diagram like structure of the database. But in this case, we have to be aware that it's actually working not on pure logical representation of our database model, but we are already in process of development of a relational database because this particular software dedicated to implement our diagram with specific DBMS. In this case, it's MySQL. And what is programming language actually had to be used has to be used for manage relational database is SQL, structured query language. So with this syntaxes, we can actually do any operation over relational database, including both database development as well as data management. And here is we have example of data management operation, like retrieving data from relational database. But again, as I said, with SQL, we can even create database, insert data, and so on. And here is we have again relationship between relational algebra background and how it's related with algebra logic and tables of truth. So again, that things had spoken on when I spoken about formalization, formal logic, and so on. They are also true for SQL. Because again, that's all based on relational algebra. And here is we can, for example, when we are simple task, we want to retrieve data which is available in both table, like teacher who had to be enrolled in 2 department or so. So here is at right side the results we are expecting, at left side source, and above within that borders what's representation in relational algebra notation. So here is we have SQL notation, which is actually quite easy to understand. And here is we have relational algebra, which is in fact not easy to understand, but it's actually theoretical background for relational database. Okay, I would be happy to present some point of NoSQL database, but we are already out of time. So very special, usually some enterprise solution. Mostly it's related to social media introduced so-called NoSQL database to provide, usually they implement network model. Network model, here is we have few type of NoSQL database and their models they are implemented. Solution housing, key value, document-based, column-based, graph-based. That's graph-based, that's exact implementation of network model. And how it could be work, again, that's very closely related to JSON format, this case, so they are better to deal with JSON, that relational database. Number of practical solutions they are available, but still, again, they have both benefits and disadvantage in both cases. And as I already said, that's real solution, real software, modern time, very often it's combined, not a single database, but few, that it's we can find number of practical products which incorporate both SQL and NoSQL database in the same software product, in the same architecture. For example, SQL database used to store organized data, and NoSQL database to store those JSONs for data exchange. Okay, that's all I want to talk about and present for you. That's example for this case. So thank you for your attention. And goodbye.